Okay, everybody. Hello. Hello there. I was informed by somebody that I made a little boo-boo with this last question that we did the other day. Slurpee, slurpee, slurpee. The mistake occurred right here, people. You know, I subtracted 3x squared over here, right? Knocked that out, good. But for some reason, I wrote plus 3x squared over here and not minus, 3x squared. So I gotta change this answer here. Slurpee. So minus, there we go, there we go, there we go. So note the change here, everybody. The derivative of y with respect to x is negative 3x squared plus 9y over 3y squared minus 9x. And like I said, you want to factor out some 3's there, You can if you want. Right, if you wanted to take out a 3, or even a negative 3, you could as well. Make that negative x squared plus 3y over, right? Factor out a 3 down there. Make that y squared minus 3x, eh? Right? And then you want to cross out those 3's. You can do that if you want. Slurpee. So it's up to you. If you're going to simplify it, just don't mess it up, right? That's all. All right, so there we go. Right? Got it. Okay, what are we doing here today? More practice, all right? This is practice time now. We've introduced really what to do here with implicit, and we'll get into different types here, but definitely this will be a little practice now. I'll do number 2 for you. All right, so hopefully you got all this down because I'm going to erase it, and you could always rewind it, because I'm going to need this space here, number 2, okay? All right, so you got all this, all right, people? All right? Need the space. So here we are, page 2, number 2. Hello. Find dy dx, right? Get the derivative. Right, remember we're gonna take the derivative of both sides here. Right? Which means, you're going to take the derivative of each term, right? That d dx is going to go to each term there. All right, so we're going to do d dx of x squared plus now d dx of xy plus d dx of y squared equals d dx of 10. All right, take the derivative of each term, And here we go. The derivative of x squared is 2x. Plus now, be careful people, okay? The derivative of x times y, isn't it? Right? X times y, eh? X times y, people, is a product rule. Remember? Remember here? It's a product rule. Hopefully that didn't mess up my video here. Right? This is a product rule. Where we do the first x times the derivative of the second. The derivative of y, remember, is a y prime or a dy dx. Plus the second, y, times the derivative of the first, x. Right, is 1. The derivative of x is 1. Plus the derivative of y squared is 2y times the derivative of the inside function, eh? Right, don't forget, dy dx. It's going to equal the derivative of 10, which is 0. So, listen, right? What are you seeing here? Anytime you're taking a derivative and there's a y, you're slapping on a dy dx. Okay? Anytime you take the derivative and there's a y there, you take that derivative, yes, and then you slap on a dy dx. Right after. All right, let's clean this up here. This is going to be 2x plus now. I guess technically this is like distributing a 1 in there, right? So like 1 times x dy dx. Now when I say x dy dx, it's x times dy dx. So 1x or just x dy dx plus 1 times a y times 1 is a 1y or just y plus 2y dy dx equals 0, people. I would now move all the non-dy dx terms over to the other side. And a minus 2x minus 1y to both sides. Goes. I'm going to have now left over 1x dy dx plus 2y dy dx will equal negative 2x minus 1y. And now remember, right? You start to see a little pattern here, people, Factor out a dy dx here. Both terms on the left side have a dy dx, right? Factor that out. And left over here on the inside is 1x plus 2y equals negative 2x minus 1y. And then isolate for dy dx now by dividing both sides here by 1x plus 2y. And there you go. Right, those guys cross out. You're left with dy dx on the left side by itself equals negative 2x minus 1y, or negative 1y minus 2x, however you write it there, over x plus 2y. And that's your derivative. They're using implicit, right, for number 2. All right, let's do number 3, and then we'll take a little break here. All right. So once again, we're finding the derivative. Let's take the derivative, right, of both sides, right, which means we're going to take the derivative of 2x cubed minus derivative here, 3y squared is going to equal d over dx of 8. The derivative of 2x cubed is 6x squared minus the derivative here of 3y squared. All right, so 3y squared will be 6y, and then don't forget, right, derivative of the inside here, dy dx is going to equal the derivative of 8, which is 0, people. All right, this one's not too bad. There's only one dy dx, So let's see here. What am I going to do? Guess I'll minus, right? I'll minus here the... I mean, you could bring that 6y dy dx, that whole term, over to the other side, right, to get that to be a positive. Since there's only one dy dx term here. Right, but I don't know, I'll stick to what I've been doing. Move the non-dx, dy dx terms over to the other side. You'll have negative 6y dy dx equals negative 6x squared, and then we'll divide both sides here, right, by negative 6y, because they, right, will cross out. Right, if it's stuck to something, right, if it's stuck to something and you're looking to isolate, you divide by that piece, right? 2x equals 10. You want to isolate for x, right? The 2 is stuck to the x, right? You divide both sides by 2. All right, so let's see here. So dy dx is negative 6x squared over negative 6y. Now, you want to leave it like that. It's fine, people, but this, is not too bad to simplify. You got, a monomial up there, the numerator and the denominator. I love that right now, oh my goodness. So here you can divide. I mean, this is not a problem, right? It's when you got binomials and stuff, it's a little bit of a different story. But here, no problem. You can cross out those negative 6's if you wish. You don't have to. It's fine. Dy over dx if you don't want to. But it's going to look nicer here, isn't it, if you write x squared over y as your derivative. All right, so that is number 3. Now, like I said, we're doing practice here, and I don't think I'm going to start another one on this piece right now. But this is going to build. We're going to, take these derivatives and do other things, with them, such as, writing the equation of a tangent line, right? So, and then I'm assuming the tangents, yes, all right, horizontal, vertical tangents. So we're going to build upon this. It's not just doing, examples of just finding the derivative. We will apply that here, such as this guy. This is a good one here, horizontal and vertical tangents. We'll get to that guy, soon enough. So yeah, we're still going to practice here on the other side. Bring back trig a little bit, I'll do that guy, number 4. And then, I don't know if I'll do all of these here. I don't know, we'll see. And then maybe I'll do that one, another trig one.